Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on regression and correlation using some alien data. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. In this set of videos, we're finally getting to using the TI-83 and TI-84 calculator to make our actual calculations. What are our goals for this PowerPoint? Well, our goals are to make a scatter plot, to find the correlation coefficient, to use the scatter plot and correlation coefficient to decide if there is evidence of a linear relationship, and if a linear relationship exists, to find the percentage of variability explained by the linear relationship, find the linear regression equation, make a scatter plot with regression line, use the regression line to make predictions, and interpret the slope and y-intercept if appropriate. If a relationship does not exist, then we will use the average y value to make predictions. This PowerPoint was created in 2010, and the course has changed slightly since then, and sometimes Mrs. Borlaug is leaving parts of these things out. I will cover all of these as if we're covering all of this in case we add them back in the future, and none of this information is useless. It is all very valuable. So we will cover all of this. And again, we are not using any of this by hand. We are using the TI-83 and TI-84 calculator to make our calculations for the scatter plot, the correlation coefficient, and the linear regression equation. If you are from another institute and are required to use different software or required to do this by hand, this may not be the video for you. As a review or introduction, depending on when you're watching this, let's go over some details. R is going to be our correlation coefficient. Sorry about that. My phone rang and I had to pause, so I'm going to back up to make sure that I have covered everything I need to do. R is the correlation coefficient, and next we have R squared. R squared, if you multiply that by 100, gives you the percent of variability explained by a linear relationship. And if R squared times 100, again, gives you a whole number, and that becomes the percent of variability that's explained by the linear relationship between your paired numbers. And that is probably a new concept if you're just watching my videos. The linear regression equation should only be used for predictions if a linear relationship exists. And to check for evidence of a linear relationship, remember we have two steps. First, to look at the scatter plot to see if the data has a general linear trend. And second, to look up the critical value in the table, and if the absolute value of R is greater than the critical value, then there is evidence of a linear relationship. In other words, if the absolute value of R is greater than the critical value and the scatter plot of the data has a general linear trend, then we have evidence of a linear relationship. And if a relationship does not exist, then the average y value should be used for predictions. Now, example number 1. With this video and in this example, we will explain how to use the TI-83 or 84 calculators to do the linear regression. The formulas for regression are very long and cumbersome, so the calculators make our jobs so much easier. Time to begin. Example number 1, male alien data. The top row is height in feet, 4.06, 4.25, 4.37, 4.46, 4.82, 5.13, 5.20. Again, the height in feet. The bottom row is weight in pounds, 87.3, 89.8, 88.7, 89.9, 92.5, 93.4, and 94.3. We will be doing 4 steps in this first example. A, make the scatter plot of the data. B, find the linear regression equation. C, make a scatter plot with the regression line. D, use the regression equation to predict the weight of a male alien that is 4.5 feet tall. And we'll show all of our work. First, there's our data again, and we'll make a scatter plot of the data. Remember that a scatter plot is a set of ordered pairs that we've graphed, and our data is paired. We have paired the top row, or each number in the top row, with the corresponding number in the bottom row. We have paired 4.06 with 87.3 and down the row. This gives us X and Y data. In general, the X data is given either first on the top or to the left, and the Y data is given on the bottom or to the right. But it is always what we consider the input used to predict the output or the Y data. So in this case, we're using the height to predict the weight, in our particular case, of our little aliens. So we're going to input the data into our calculator as our first step. Now we know how to input one list of data in our calculator. We've covered that in previous videos. We press Stat, then choose Edit under the Edit menu, and that brings up our list. In this case, it's very similar, except we have paired data. Our X list, the height in feet, will go into list 1, and our weight in pounds will go into list 2. Notice we do not put all of our numbers into list 1, but create 2 separate lists for our 2 values. So list 1 is our values of our X's, and list 2 is the values of our Y's. List 1 is our height in feet, list 2 is our weight. Notice how that means 4.06 corresponds to 87.3, 4.25 corresponds to 89.8, 4.37 corresponds to 88.7, and so forth down the list. So to make the scatter plot of the data on our calculator, we will hit Second, Stat Plot, and the Stat Plot is above the Y equals key on your calculator. We will then select Plot 1. You should get a screen that looks similar to the screenshot on your calculator. Plot 1 is highlighted. On is highlighted. The type is that first scatter plot type shown. Make sure it's highlighted. Our X list will be list 1. That's where we put our X or input values. Y list is list 2. That's where we stored our second list, our weight in pounds. And the mark, we'll choose the first mark as it's the largest mark. Then we'll place and choose Zoom, and then go down to number 9, Zoom Stat. This sets the window to the appropriate values. This is a shortcut. The calculator looks at your data and selects a window for you. Once you've done that, you can select the word Trace, and it will let you move from each of the ordered pair points to see what the data values are. Alternately, you could select Window and put in appropriate axis values yourself by hand, and then press the word Graph or the key Graph. So we now have our scatter plot. Notice that the graph is going to be labeled on the axis, and it's on the screen as X and Y, but for our case the X is the height in feet. That will be our horizontal axis. The y-axis is the weight in pounds, which is our vertical axis. On your paper, as you do your exercises, you will be asked to make a sketch of this data, and you can use some rough estimates and make a rough sketch of this. We're not asking you to be exact. These numbers, you're not going to be able to graph exactly 4.06. We just want you to get, in general, a rough sketch of this graph. And this is the scatter plot of the data. And this is a great place to pause the first video, and please watch the second video where we will pick up finding the linear regression equation.